Hi everyone, and you are welcome to this lecture, Computer Algorithms. In this lecture, I'm going to define what an algorithm is. We will understand the difference between an algorithm and a program. Also, I will share with you a complete example about an algorithm. Finally, I will end up this lecture by a quick summary. So let's get started. Usually, when we have a problem and we want to solve this problem using computers, the first thing to think about is the solution algorithm. So what's an algorithm? Algorithm is an ordered set of defined steps in order to solve a problem and obtain a logical result within finite amount of time. From this definition, we can understand that the algorithm represents the steps that should be implemented inside the program in order to solve the problem. Usually, we formulate any algorithm by defining the inputs, the outputs, and the steps that map the inputs into the desired outputs. Also, a very important point to know that when a problem can be solved using multiple algorithms, and over the time, you will get the required experience to know the best algorithm quickly. And usually, we compare between algorithms using different factors such as execution time. So for example, we say one algorithm is better than another if they achieve the same target but it requires less amount of execution time. After we understand the meaning of algorithm, now we should be able to discriminate between an algorithm and a program. Simply, algorithm is just a problem solution description in which we define inputs, outputs, and the steps, whereas a program is just the actual implementation of that solution using one of the programming language. So the algorithm represents the solution, whereas the program represents the implementation. Now, to understand the idea better, let's take a complete example about an algorithm. Assume I have the following list, 1, 5, 3, 4, and I want to know the maximum number inside this list. You as a human directly you will say, the maximum number is 5. And it's a very easy problem for you because this list has only 4 items. But what if this list has 1 million items? It's very hard to be solved by you directly as a human, and you have to use a computer. So you have to start to think in the way that the computer thinks. In other words, you have to set a solution algorithm in which you have to define inputs, outputs, and steps. In this problem, the input is a list of positive numbers, and let's call this list L, and it has the following items, which are 1, 5, 3, 4. Whereas the output is the largest number in this list, and let's call this largest number n. The algorithm steps will be, first of all, I will set the initial value of n to be 0. Then for each number x inside the list, I will compare this number with the largest number, which is n. If I find that x is larger than n, I will update the value of n by the value of x. I know that the steps could be not very clear, so let me explain these steps visually. First of all, I have the following list, which has 1, 5, 3, 4, and I will set the initial value of n to be 0. Now I will compare the first item, which is 1, with n. It's clear that 1 is larger than 0, so I will update the value of n now to be equal x, which is equal to 1. And now the largest value found until now is number 1. I will do the same comparison for 5, and I will find that 5 is bigger than n, which is 1 in this case. So I will update the value of n by 5. If I do the same comparison for 3 and 4, in both cases I will find that the value is smaller the value of n, so the value of n will not be updated, and I will keep the value 5 inside the n. Now, because I reached to the final item, which is 4, no more comparison required, and the variable n will have the largest number, which is 5. And that's all for this example. Now let me summarize what we have learned in this lecture. First of all, an algorithm has been defined as an ordered set of defined steps in order to solve a problem and obtain a logical result within finite amount of time. Also, we say if we want to formulate any algorithm, we have to define inputs, outputs, and the steps that will map inputs to the required outputs. Also in this lecture, we have discriminated between algorithm and program. And simply we say an algorithm is just a solution description, whereas the program is the concrete implementation using one of programming languages. That's all for this lecture. Thank you very much for your time, and if you are available, join me in the next lecture.